the last event in our lecture series for Unfolding the Universe, Wandering Through Time and Space. And we're here today with Maggie Masetti. And do you want to give your spiel of like what you have to say?
Yeah, so I am a NASA contractor. I work at NASA Goddard in Greenbelt, Maryland in the US. I am here just representing myself and the work that Ashley and I have done together. And I am traveling on my own dime and I'm on vacation. So I'm just happy to talk about the things that we've done together.
Not here representing NASA.
No,
today,
I'm not representing
in an official
NASA
capacity.
In an official capacity,
yeah,
no.
There we go. So thank you for joining us. We're going to give a quick talk about the exhibition and the history of what led us here. One of the biggest questions that I get when I'm talking about my artwork is how I got started with NASA and why, like how and why I'm doing this. So,
right.
And a lot of that has to do with Maggie. So I'm very happy to have her here today. She flew all the way from the US to be with us and give us.
It was a terrible hardship to be here in this beautiful city. So.
Okay, so Maggie's going to get started by giving us a brief introduction of the Webb Telescope. If I can get my slides to work. There we go.
Yeah, so this is us both in front of the actual James Webb Space Telescope. How many of you have heard of the James Webb Space Telescope? Oh, good.
Oh, wow.
Quite a lot of people. So, and I'm sure anyone on space.com is probably going to be familiar, but I'll just give a quick overview. So the James Webb Space Telescope is the scientific successor to the Hubble Space Telescope. It doesn't orbit the Earth. It orbits the sun 1 million miles, 1.5 million kilometers away from the Earth. It's a giant infrared space telescope. So the way that NASA makes science decisions and the astronomical community makes science decisions is they look at all the things and say, what do we want to study next? And it's called a decadal survey. So every 10 years, what are the new priorities? So one of the things they wanted was to be able to look back into the early universe to see when the first stars and galaxies started forming, because it's one of the things we don't really know very much about. Hubble cannot see back that far.
Because Hubble's working in the visible light spectrum.
Mostly visible, a little bit of ultraviolet, a little bit of infrared. Has a much smaller mirror than Webb. So they built Webb specifically to optimize it for seeing infrared light from things really, really, really far away. We're talking a couple 100 million years after the Big Bang. So it is beautiful. It has this open-faced mirror. It's coated with actual gold. It's only about the mass of a golf ball coating that entire mirror, which is 6.5 meters. And gold actually optimizes that mirror for reflecting infrared light. So this thing was really built to see infrared light. And the reason you want infrared is that thanks to the expansion of the universe, the things that are in the early universe, their light, by the time it gets to us, as it travels through space and time, and as the universe expands, the light expands too, and that visible light gets stretched into the infrared. So in order for us to see back that far in those first stars and galaxies, by the time their light gets to us, it's in the infrared. So that's why we built this. Do we have the international partnership thing next? Or so this is actually a collaborative endeavor between NASA, the European Space Agency, and the Canadian Space Agency. And there's also a number of partners. We can get more into that later. Do you want to back up just?
Yeah, do you want to go talk about this?
Yeah. So there's also a number of companies and other organizations that were involved in building the space telescope and developing the science priorities for it. So as I mentioned, I actually work at NASA Goddard. This telescope was built all over the country, and 2 of the instruments were built by the European Space Agency as well, and one by the Canadian Space Agency. The mirror sits on top of a giant sun shield. So the thing with infrared light is that it's perceived as heat. So you really need a cold telescope to be able to see faint heat signals from things really, really far away. And that's also why we're so far away from the Earth, because the Earth, the sun, and the moon are really bright and warm. And so it's going to swamp this telescope with all that light and heat. So at all times as it orbits around the sun in line with the Earth, it keeps this giant sun shield, which is the size of a tennis court, pointed at us, blocking the light from the mirrors and the instruments. It's actually 5 layers of a substance called kapton. It kind of looks like, you know, those like shiny Mylar party balloons. It looks and feels like that. It's very thin, but it has different, you know, thermal properties than a party balloon. But 5 really thin layers is enough to keep that telescope nice and cold. It's in the dark and the shade. And it stays cold purely by virtue of being in the shade. One of the instruments has a secondary cooler, which makes it even colder, but really it's in the shade. And this particular picture was when the mirrors and the instruments were mounted on the sun shield at Northrop Grumman. Do you want to go to the next one?
Next one.
So
this is where the story begins.
This is where the story really begins, but I wanted to make sure you kind of knew where we were starting with the telescope. So as I said, we built part of it at NASA Goddard, which is they assembled the mirrors. So the other thing about this is that the telescope mirror is so big that to fit it in a rocket, it has to fold. So you can kind of see that the mirrors actually are segmented. There's 18 hexagonal segments that kind of fit together. Hexagons are great because they fit together without gaps, roughly circular, symmetrical. But I had the great honor of witnessing this come together at Goddard. And once it was sort of finished, we had a big press event. And I'm the social media lead for the mission for NASA. So I was asked to put together some sort of a social media event. NASA has these things called NASA Socials where people can apply to come and get some sort of behind the scenes experience and they can share it on their social media channels. A lot of times it's like a launch. I wanted to do something a little different because that gold mirror is absolutely beautiful.
Yeah.
It's really stunning and spectacular. And I have a lot of artist friends, and I know that a lot of them have very big social media followings because it's also always our goal to try to put our mission in front of people who might really enjoy hearing about it but aren't natural, maybe space fans. So artists seemed like a good fit for that. And also I had met this artist at AwesomeCon, which is a science fiction convention in DC. And he had all this space art, and I'm like, "Do you have, James Webb Space Telescope?" And he's like, "No, someone said I should wait till it launches." I'm like, "No, you should do art." So he was in town for a while, so I gave him a tour, and I did not ask him for anything. But a week later, he emailed me like a piece of art that he created, inspired by it, and I was so amazed by that. I thought we have to get artists in front of this because the telescope is so beautiful and it's so inspirational. That it would be a really cool event. So we had people apply to come sit in front of the telescope and create art.
That's me.
And that's Ashley. We did not know each other. She was an artist I picked totally cold out of the applicants. I tried to pick a different range of artists, so not 10 watercolorists. It was really challenging because there's so many talented people that applied, and we ended up later doing like a social media campaign because the space was fairly small, so we could only take about 22, 25 people. So I tried to pick from all different, artistic media. So Ashley was one of the people I selected. So on the day we had this set up really beautifully with the telescope was beautifully lit. I had tables put in there. We had some speakers. So in the middle is Dr. Amber Strawn. She's one of our astrophysicists. She talked about the science. We also had 2 engineers, and people sat there and asked questions and talked to our speakers and sketched. And we actually had someone write a song about the telescope, and he shot a video of his song in front of the telescope, which was really special. So that's more photos of the actual event. This was our clean room at NASA Goddard, and we have this observation window, so you can see what's in it. Clean rooms are important because humans are, we shed hair and fibers, and to keep space hardware super clean, we have it in this clean room. You can almost see the wall behind it. There's nothing but HEPA filters on the wall inside the clean room. Next. Right. So after this artist event, which went beautifully, a couple months later, people were creating art. And again, we didn't ask anyone to do anything. There were no obligations with this event. We just thought it would be really cool. And people started actually creating art. So we started thinking maybe we should have an art exhibit. And I was given space at the NASA Goddard Visitor Center, and 90% of the artists created at least one piece, some of them multiple pieces. And again, all across a range of different media. So Ashley, you can see we'll have more pictures of her sculptures on the podium there. We had textile art and music, and we had, on the right there, she's reading poems she wrote about the telescope. So we had an opening night party, and we had performers, and it was
a fun party.
It was a really special experience, yeah.
That's my
So-
sculpture.
Yeah, and she made little mini ones for me and Amber, and I still have it in my office.
Yeah. Whenever I work with scientists, I try to make a mini version or something to give them for their participation in the collaboration with the artwork. So that was my tiny miniature 3D printed version of the big one.
You should talk about your actual, I don't know if it's on the
Is
next.
it on the next slide? Oh, no.
No.
We'll go back to the sculpture later. And I'll explain a little bit more how I came up with it. You can talk more about
Yeah, so
about art.
again, this event was, and the exhibit was such a success, but I felt so badly that I could only pick a handful of people that we thought, hey, we should open this up to social media. So, if you create art inspired, do you want to press play on the little video? If you create art inspired by the telescope, send it to us and we'll post it on our social media, and we have like a gallery. And I apologize that this is relatively fast. We have over 500 pieces in the last couple of years that people have sent to us. And I'm just quickly scrolling through our gallery. You can get an idea of some of the range of things that people have submitted via social media. So we started this in 2017. The artist event was in 2016. The exhibit was in 2017. And since then, we've had over 500 submissions. And then when we got closer to launch, we wanted to do something art related as well. Do you want to go to the next slide? This will just scroll forever.
have to pause it.
So around launch, we started the Unfold the Universe campaign, and we had people think about what they thought Webb might see and send us either a photo or a video of them and their art. Do you want to press play on this one?
I don't know why this one's not giving me oh, there we go.
Oh, there we go.
Yeah.
So we have more pictures in here of people with their art because that was our initial ask. That wasn't an obligation. People give us haikus. Again, a really wide range of things submitted. So we had another couple hundred pieces submitted specifically for the Unfold the Universe campaign, which was right around launch time. Some of the pieces kind of overlap with both the JWST art hashtag, which was our first campaign, and Unfold. So again, hundreds of pieces, and they came from all around the world, which was really rewarding as well. We had a class of children in Maldives, the islands, submit their art, and countries like Iran and all over Europe and just all around the world, people submitted their art, and it was really special.
Oh, it wants to go all the way through the video.
Oh no.
Slide. Let's do the next slide. There we go. Oh, that was your slide that you were talking about.
Oh yeah. So this is the list of the countries, including some of them from Lebanon, Hong Kong, India, Philippines, and people from toddlers to senior citizens, small children. It was really rewarding. This is the one where you can see the people and their art. I don't know if you want to press play on some of it. Or not.
Gotta love the Wi-Fi in here.
That's okay.
Yeah. Okay.
You can find all this
Yeah, you can download
on our
the
website as well. And if anyone else is inspired to create art inspired by the Webb Telescope, we are still collecting pieces for our galleries.
Okay. Do you want to explain this one? Super secret. Maybe I'll explain it.
Maybe you should explain it.
Yeah, just, So this is a paper that Maggie and I wrote with a couple co-authors that we published earlier this year. It is currently redacted for infringing upon DEI violations, but we still thought it was relevant to share here today because we've written now 2 papers and published 2 papers about how art can make science more accessible and like easier to comprehend and bring more people into the fold that maybe wouldn't be normally into space or feel it's accessible to them.
I mean, I think over the course of this, it started out just like it would be fun to have people create art inspired by the telescope, but through the process, and then that was 10 years ago, and Ashley and I have, stayed in touch and became friends, and we've collaborated. She'll talk a lot about some of the other things we've collaborated on, but we realized how special it was that you could use art to bring people who think science isn't for them to science, because science and space really are for everyone. But a lot of times people have this mental block, like, oh, I'm not good at math, so science isn't really for me. But that's not really true. And as well, there's other ways to make science accessible, like across language barriers and cultures, and art is so good at bridging those things.
Our second paper was specifically focusing on
inclusion of
like non-sighted people,
right?
People from different backgrounds, and how art can make these. You can make sound art so people can hear the pictures.
Yeah, the blind and low vision community can use sound. So some of the web images, once we launched and had images, they did sonifications of the images so that you could get a sense of what the image was converted into like a soundscape.
Okay. Now we can talk about my sculpture that I created for Maggie's event.
For our original one. Yeah, this is the one she exhibited.
Yep. So this was in the NASA Goddard Visitor Center for the exhibition, and then later went on to be in multiple exhibitions from there. So yeah, I got to see this amazing telescope. Obviously, it's gorgeous, it's beautiful, but I wanted to go a little bit further than that. So after I went home, after the event, I immediately think I emailed you, and I was like, I'm coming back.
Fortunately, she is local because she is based in New York City, and we're not far from Washington, D.C., so it was easy for her to come back.
Yeah, it was an easy trip back, but yeah, they couldn't get rid of me. I was hooked then. So my background with getting into working with NASA is, I'm an artist. I'm traditionally trained. I have no science background. I have a degree in sculpture and art history. And I did a program called New Ink at the New Museum in New York City. And I applied for this program partially because one of the advisors on the board of that program was also on the board of the SETI Artist in Residence program. And I really wanted to go out to SETI. So I don't know if you guys know what SETI is, but it's Carl Sagan's search for extraterrestrial intelligence. So it's basically the movie Contact. It's radio astronomy, so radio telescopes. And I went out to Hat Creek Radio Observatory in Northern California, and I spent a summer out there working with Jill Tarter and learning about radio astronomy. And one night when we were out laying in the telescope field, looking up at the stars, this was the first time I had ever seen the Milky Way.
New York City.
In a city. So I had never seen the Milky Way before, and it was amazing to just be laying out in this field with all of these scientists and having them, point things out to me, and we could see the ISS pinging across the sky. And I was so moved by that I was like, okay, I'm hooked. This is like what I do now. And the next day we did a field trip to NASA Ames, and I got to meet all of the scientists at NASA Ames and learn a bit about the research that they were doing there. And they were like, you should go to a rocket launch at Kennedy. So I immediately applied to go to a rocket launch at Kennedy. I saw the OSIRIS-REx mission.
Oh, that's special.
Yeah, and that was like a couple months before this, because I was at the OSIRIS-REx launch, and somebody was like, have you heard about this cool new telescope up at NASA Goddard? And I was like, no. And they were like, you should go. And then I saw your open call, and I went. And after having hopped around to several different missions and different NASA locations, then I was like, okay, this is where I'm going to be. And so, yeah, now these people are my family. We've been working together for the better part of a decade. And
yeah, unofficially. The first event was a NASA event, but we've become friends and just, on our own.
Yep.
Like work together.
Yeah,
NASA
doesn't have an artist in residence program or anything. This is all on the scientists and engineers' own accord.
Correct. Yeah.
We have to say that. So yeah, after I saw the telescope, I was so moved by it, but I wanted to go like a level deeper and talk about why the mission was important and what people were hoping to discover. And one of the amazing points that Amber made was, it's hard to sell a mission to people when you're trying to sell them on the unknown. People always want to know, well, what do you hope to discover with this? What are you looking for?
What are the images going to look like?
What's it going to look like? And that's, you don't know. That's the whole point of exploration, is like diving into the unknown. So this sculpture is called Exploration, and it's the arms. It's my arm, the arm of Dr. John Mather, who was a Nobel laureate.
He won his Nobel Prize for proving the Big Bang Theory is correct. No big deal.
No big deal.
Yeah, he's also literally the nicest human being
Yeah.
you could ever hope to meet.
Yeah.
He's wonderful.
No.
And he's also willing to do any kind of crazy thing that we ask him to. Like, how would you feel about giving a talk in a virtual world? Like, he's like,
he's
sure.
such a trooper.
Yeah.
So yeah, we 3D scanned Dr. John Mather's arm and
Dr. Amber Strawn,
Dr.
who was
Amber
in the
Strawn.
picture with us earlier holding the little mini
Yep.
statue.
And then I worked closely with John to decide, so there's actually text wrapping the arms that are pushing through the mirror. And so this is kind of like reaching into the unknown. What are we going to find, you know? And the metrics that are wrapped around the arms are the metrics that are like, you know.
Yeah, we combine the equations for like a parabolic telescope dish and Einstein's like relativity equations.
Yeah. So it's basically information that was used in conceptualizing and building the telescope.
Yeah.
And then it's 3D printed and gold plated, and I actually found NASA's gold plater, so it's plated in the same gold as the telescope, and I think might have more gold on it than the telescope.
It might. It's like a hair.
Yeah.
On the real telescope. Yeah, so launch. So
the show was in 2016?
Yeah, it was 2017, actually, spring 2017. And we're actually almost exactly, it was early November of 2016 was the original. So we actually launched in 2021 in the midst of the pandemic. And then we had a 6-month commissioning process to cool down the telescope, make sure everything that aligned the mirror segments, and there was a bunch of tasks that had to be done before we could get our first images. You might imagine with 18 mirror segments, you want them to work as one, so there was a whole process. But everything, we had to deploy the telescope too, because it was all folded into a rocket.
Do you know how many single points of failure?
It was like 370 something.
Like that,
yeah, it was a very complicated piece of hardware, again, because it had to fold to fit in the rocket. But deployment, which took about 2 weeks, went absolutely beautifully. And then another 2 weeks to get out to where it was going to orbit the sun, 1.5 million kilometers away. And then 6 months after launch, we had our first images. So, but around launch, Ashley and I started talking like, hey, we want to do something cool together. What can we do? And then, of course, the pandemic hit, and we're like, well, we won't be doing anything in person.
I guess we won't be doing anything.
Yeah.
Well, and I spent my my time in lockdown teaching myself VR, because why not? All my shows had been canceled for the year. No physical art was being bought or sold or shown. So I went purely digital, something that was in my practice anyway, but I had always taken things out of the computer and made them physical for, you know, practical art
I know, it was the
reasons.
opposite.
Yeah, but then I was like, okay, I guess this is time, you know, well spent if I focus on my digital practice now. So this is Unfolding the Universe, was a VR experience that I created and conceptualized with Maggie, basically, because we were just bored and chatting each other out over Zoom. And I did a bunch of interviews with different scientists and engineers on the Webb team, lots of Zoom calls, chatting, asking questions, and I recorded them. I made a virtual reality landscape with the original sculpture as the center, only animated and digital this time. And then you can walk around the space and interact. There's portraits of each scientist or engineer that I talked to, and it's all sound mapped, so you can walk up to them and you can hear little clips of our interview of them. You know, the questions get really, really deep too. Like it went from like a history of like, you know, why are you working with the Webb team? How did this come to be? All the way to why are we here? What's out there? And like the big mind-blowing questions. And so I built this space, and then we launched it on the day of launch, which is Christmas Day. So that's me in my Christmas pajamas in my virtual world. And we held a launch party where we watched the launch in VR with a bunch of people.
Did we start the talks before lunch? So this space was really cool. She also had a secondary room where we invited some of the artists from the original exhibit to virtually have their pieces displayed in this gallery. It was like the waiting space, and people who attended the virtual talks in here could look at the art, and then we'd have them come into this other space where the interactive portraits were, and we had like a speaking space. So John Mather, bless him, we're like, hey, you want to try this out? He was our very first one. We probably should have held the Nobel laureate for like when we were like more
better at it.
Yeah, but he was our guinea pig. So he gave a talk in this virtual space, but it was challenging too because the amount of server powered, like how many people can you have in here watching the talk before it all like crashes?
Yeah, this was like the beginning days of Mozilla Hub, so we had to work one-on-one with Mozilla to make sure that we weren't crashing their servers when we did an event. As you can imagine, when NASA tweets out a link.
Right, which was challenging too because we have like the NASA social channels from, you know, sort of user generated content and these like experiences that users could attend. So we were able to, you know, invite people to sign up for this free talk through here. And we actually held a series of talks. So John was our first one, and a lot of the scientists and engineers that were featured in it actually came and gave virtual talks in the space.
Yeah, this is John's little avatar giving a lecture on apparently the chemistry of exoplanets, which is cool. So yeah, this is the space. That's the sculpture digitally. And then I decided, since I was then released with the laws of physics, I was able to like make things fly and spin and move, which was interesting.
And you can see the purple portraits around the back. Those are the ones you could interact with.
Yeah, and the purple portraits are all the scientists. And you can try it here. Also, at the end of the lecture, there's a QR code where you can download everything.
Yeah, so 6 months after we launched, we had our first images and data released. So these represent really like the sort of the science themes and the capabilities of the telescope. So star forming regions, the early universe, galaxies and how they form and evolve. And this is like a sun-like star at the end of its life. It's a planetary nebula, and this is a spectrum of an exoplanet, because I find exoplanets such a fascinating field. They're very hard to explain to the public because you end up with a lot of graphs that are very scientifically significant, because it's pretty amazing that we can look at a dot of light from a planet around another star and then it can tell us what the atmosphere is made of, even what the weather is like on that planet. We can direct image exoplanets, but it's like a dot, because as you imagine, an exoplanet is really, really small and really, really far away. And it's like galaxies are enormous. So, you know, it would be harder to get like the detail of a grain of sand 10 feet away than, you know, a mountain a mile away.
Also, out of the first 5 images, like obviously the graph is like sadly the least exciting.
I know, but scientifically it's so exciting.
Yeah, that's gonna be important for later, because I made artwork about spectroscopy. That's gonna launch next month.
So this is, again, just like the tip of the iceberg. So that was in July of 2022. And since then, the telescope is just functioning beautifully, just even better than anyone expected it could be. And it never ceases to thrill me to see new images, because I was so lucky to see it come together, you know, right in front of me, and then to know that it's out there doing amazing science and capturing these beautiful images is, so special.
Yeah, so after making 2 works of art talking about a telescope that nobody knew about, this day was very important to me, because finally everybody knew what I was talking about, because it was kind of like the images seen around the world. I got text messages from so many people saying, like,
they were displayed in like Piccadilly Circuit and Times Square and all over the world. Like, it was a big celebration. It was so cool.
So finally people understood what I was yapping about for like years. And I actually got to be at NASA Goddard with you guys.
We had a social event, like a NASA social, that wasn't really like for artists, but we had people apply to come to be a part of like the presentation, the first unveiling of these first images. I did not get to go to it, even though I helped plan it, because me and my team were pulled up.
You had to work on
we're in a conference room, like as they had a live broadcast, and we're like like publish the image on cue because it had to be all very like, carefully done. So we're in a conference room like, okay, publish.
It's okay. I rep the team for us in the auditorium. Okay, so yeah, once I got to see the first images that everybody had been hyped up for like so many years, I had a solo exhibition at Onassis Onyx Studio planned for that November.
It was fall of 22.
October. It was October.
Yeah, it was October.
So the images were released in July.
July
Mm-hmm.
July 12th.
July 12th. And then my show opened early October. So I only had a couple months to make an entire body of work based upon these photos. So I basically drove home from NASA Goddard and was just like thinking about what I was going to do the whole time I was in the car. And so this piece is the Southern Ring Nebula. So
go back a slide.
It's
this one
right here. It's based on this first image. So I tried to make a piece of artwork about each of the first 5 images for this exhibition. So because the Southern Ring Nebula is a star that's exploding, and it's shooting out all kinds of star stuff in these rings, these concentric rings that are coming out from the center. So this piece is, I mapped out each of the rings, and then I took each pixel of light and assigned it a star, and then I ran an algorithm that would randomly generate the stars. So the Webb telescope has this iconic 6-pointed diffraction
they're called diffraction spikes. You can tell a Hubble from a Webb image because in a Hubble image, the diffraction spikes, like on a bright object, like a point source, like a star, are like just like a crisscross basically. But because we have the hexagonal mirror and we have the secondary mirror is on a tripod, like the shape of the mirror, the shape of the telescope, and the tripod add up to creating this diffraction spike pattern. So Webb has, they're really 8 points, but there's 2 tiny ones. So it's like 6 points with 2 tiny ones. And you'll see this motif represented in Ashley's work quite a lot. It's really, can you go back to the first images?
Yeah, you can see
you can see like the bright objects. If you ever see an image with that pattern on a bright object, that's a Webb image. And if it's just like a cross, then it's Hubble.
But I thought it was really cool that you can tell a Webb image, like if you're looking at it, you can spot the stars immediately. It's like the telescope giving a little signature on each of the photos it takes.
Yeah.
So I use this as a motif throughout a lot of my artwork. So you can see the artworks next to you. I'll have the 6-pointed stars in there. And then in the center of this, the Southern Ring Nebula, there's 2 aquamarine gemstones that are placed in the center that are representative of the
star that has shed its layers.
They sound like a binary star system.
Some of them are there's 2.
And so
often the one that's dying has like a partner, and sometimes that affects the shape of the rings too, the gravity of that system.
And this is another piece based upon Stefan's quintet, which is the galaxy image that we saw earlier. And it's several different galaxies in the system, and they're kind of like in this dance, and they're pulling each other closer. And actually, a couple of them are in the process of colliding.
Right. I think the majority of them are interacting, and then there's like one in the foreground that actually isn't anywhere near them, but from our perspective, it looks like it is.
Yeah. And so when I saw this image, I saw it as like a dance. And so this is Le Dance, and it's an interactive hologram. So the images don't really do it justice. It's very hard to take a picture of a hologram. But these are 3-dimensional images. So these are special screens. They're called looking glass displays. And they will show this 3-dimensional image. So it's actually a 3D model inside this little box. And when you walk up to it, you can like look around it, and it's a floating 3D model. You're not going to get that from these images though. And then on the larger screen here, it's still a looking glass display, so it's still a hologram, but this one's interactive. So I used a leap motion device, which is, it's a hand tracking device, and it's plugged into the computer, and you can actually wave your hand over each of the galaxies, and they'll spin and they'll sparkle, and you can move them around and stuff. You'll also see that the women with the galaxies on their head is also a motif in a lot of my work. Whenever I talk about galaxies and how they move and how they interact, I try to personify them as these like sexy galaxy-headed ladies. There's a sculpture in the front gallery that's talking about gravitational waves and how galaxies make gravitational waves. It's also represented with the women. This is the deep field image. This is one of my favorite Webb images, just because it's the first one, and it's got a good history. Do you want to talk about the history of the deep field as it pertains to like Hubble?
Yeah, sure. So you might have heard of the Hubble Deep Field. It was actually a fairly risky thing. They're like, why don't we take this telescope that has a lot of people that want time on it? So, using up a lot of time for like, you don't know what's going to happen. It's like, is this going to be a giant waste of the telescope's time? But they aimed it at a little empty patch of space for a long period, and just they didn't know what they'd see, but what they got back was like, yeah, like all these, very distant galaxies. So the deep field's very famous. We know what it is now, but when they did it, they didn't know what they would see.
Yeah.
So it's pretty iconic. So of course with Webb, they did deep fields as well. And one cool thing about Webb was that the very first thing that Webb put out was actually like an image of a single star, like a point source, because they're working on calibrating the instruments and and the mirrors and everything. And so it was just supposed to be a single star in empty space. And when they got the image back, there's all these galaxies behind the star. So really, like every Webb image is like a deep field image, which is pretty amazing.
Yeah.
But one of our first images, it was the very first one that was revealed, was an actual deep field from Webb.
So this piece is representing the process of how Webb takes an image. So I worked with a couple people at Space Telescope Science Institute. So
they're actually the ones that processed the first images.
Yeah. Joseph and Elisa.
Yeah. They're amazing.
They process all of the images. So Space Telescope is an institute that takes all of the information that's downloaded from Webb, and they actually process the images.
Right. There's a huge data archive there. So anyone who knows what they're doing with data processing software can actually go to the archive and download Webb data. It's available for free for anyone. You'd have to know what you're doing with it, but you can process your own images. But when we release them for science releases, we have a bunch of people who they do this professionally, and these two people were chosen to do the first images, and they were very secretive. Like the first images were very heavily embargoed, unlike pretty much anything else that we do.
Yeah.
But Joe and Elisa did those first ones that you saw.
Yeah. And so the process of creating these images is there are multiple layers and multiple wavelengths. So the telescope will take several different images over different wavelengths and then make a composite image. So I saw this process as very similar to silk screening, where you're taking different colors and different color channels and layering them to make a complete image. So I asked Joseph and Elisa to undo all of their hard work, and instead of giving me the composite image, give me each wavelength. And I created the silk screens out of them, and then gave each one a color and made a composite image to represent the process of how these images are created. A little bit different though, because we're working with paint and pigment instead of light. So I had to kind of work a little backwards. And so these were the speaker events that we did at NASA's Onyx in New York City. So similar to this exhibition, I did a lecture series with scientists and engineers.
And John Mather again, our guinea pig.
John Mather again being a champ and coming and giving a talk. So we did several different, I think we did a couple every week. For the entire month. And then we also did a tech panel with all of the technology that was used to create the exhibition. So Mozilla and HTC and a bunch of people.
And all these team members were representing themselves as well. This was sort of done in cooperation with members of the telescope team. It was really Ashley's event, not NASA's.
Yes. And so we didn't know at the time, but people dug it, like they were into it. So we ended up getting quite a bit of attention for our Webb Telescope art exhibition in New York City. Got a really big article in the New York Times, Smithsonian, Space.com, shout out to Space.com for always being supportive. A New Yorker article, and then eventually I was approached by the Whitney Museum to create a piece for their art port collection, which was really cool, and we'll talk about that later. But yeah, very, very cool to see a positive response to this type of work and to sharing this type of science with the art community. And so now that brings us to today. So this is Unfolding the Universe, an ESA web experience. So my first virtual reality experience was mostly, it was all NASA scientists and focusing on NASA's contributions to the Webb Telescope. But like Maggie said earlier, it wasn't just NASA's mission. It was NASA, the Canadian Space Agency, and the European Space Agency. So this virtual reality experience, which you can try out on the headset after the talk, is focused on, is all interviews with European scientists and engineers and focusing on their contributions to the Webb Telescope. The centerpiece for this VR experience is the Ariane 5 rocket, which was a big contribution.
Right. So aside from several science instruments, the European Space Agency also contributed the launch vehicle and the launch site. So she said it's an Ariane 5, and we launched not from Kennedy Space Center, but we launched from Kourou in French Guiana. So ESA has a spaceport there. So, and it's advantageous to launch close to the equator, because as the Earth spins, you get a little bit of an extra kick when you're at the center of it. So that's where we launched from.
Yeah, and so it was really important for me to present this work over here and to focus on, the Europeans' contribution to the mission and just this overall feeling of when the world comes together, we can do really big things, and you can't do these really big things without worldwide collaboration. So there's a lot of focus in the interviews around that.
Mm-hmm. Yeah, so on our website, which is nasa.gov/web, one of the things, many things we have maps of all the contributors. So we have a worldwide one, but for this talk, we wanted to focus on Europe's contribution. So, and I think the next slide goes in even further, and particularly the Netherlands, because that's where we are. So there were quite a few contributors to the telescope, science and instrumentation from organizations in the Netherlands as well. So it really truly was an international collaboration, which is, I think, really special.
Yeah. And tomorrow we're giving a talk at
Sept.
So we're actually going to be at an ESA
in Noordwijk.
Yeah, giving this talk tomorrow with the scientists.
And I think the next slide is the language cards, right? Yeah. So one of the things that we've done on our website, and we did a set before launch, and we had to update it for after the launch because they kind of got outdated. We have facts about the telescope translated into 40 plus languages. We made sure we had all the sort of ESA member languages, and so you can find them on our website. There's quite a few of them, and of course I wanted to highlight Nederlands.
And this is where we are now. So I'll give a tour after the talk as well and walk around and give you, more insight on each of the pieces. But the front room is focusing on mostly nebulas and creation and destruction, which is why we have like the pulled apart, deconstructed tapestries, thanks to Out of Steam. Shout out to Taja in the back. She helped me make them.
And that's the Carina Nebula, correct?
And that's the Carina Nebula,
which is one of our sort of first images, and it's probably the most iconic.
I think so. Yeah, most iconic web image. And then there's a lot of focus on the pillars of creation in the front as well. There's some laser cut canvases. So this goes back to, it's kind of like a throwback to some of my older work when I was doing less astronomy and more computer science, where these are images, and I have a computer program that reverse engineers them into the original hexadecimal code that the image is made up of. So every file is code, and so I'm just revealing the code and then putting it back on the image. And so these two laser cuts feature Dutch scientists in their studies. Like some of the first astronomers were Dutch. So
there's a lot of things, especially in the solar system, named after Dutch astronomers. And it's going to be the American pronunciation, but the Kuiper Belt and the like there's many things, many famous Dutch scientists who contributed to astronomy.
So just trying to bring it back to the history of where we are and the contributions that were made. Okay, So yeah, this is what the back room usually looks like when you guys aren't all here. So we have a video that'll play that kind of flies through a bunch of my virtual reality landscapes and takes you on a journey and highlights a couple scientists.
And there's the galaxy
The
ladies that you were
galaxy
talking
ladies
about.
that are in and they're, you know, touching the Webb telescope and creating gravitational waves that are interacting with one another. And then we have more nebulas over here as well, using a similar concept to the Southern Ring Nebula one that was shown in New York. And here is our lecture series that we've been doing here. We've had several scientists and engineers give talks.
And this parallels what she did in New York with having the scientists she interviewed for that particular project speak there. So she replicated that here with some of the European scientists and engineers.
But it's really cool getting to present this type of science to an art community.
Oh yeah.
To see what everybody thinks of it and just be able to share something that probably, I don't know if it would be accessible, or I don't know where you would go to do something like that. So yeah, I'll give you like a brief overview of like other works of art that I've made, just to show you just how nerdy it gets. This is Yerkes Observatory. So it's an observatory in Wisconsin, and they commissioned this piece, Time Will Tell, and it's marble, copper, and quartzite, and it's showing how massive objects warp space-time, and it's using Einstein's equations that are on the outside of the sculpture. So it's such a historical observatory in the country that I wanted it, you know, I wanted to use more traditional materials to talk about it, because I felt like it matched the historical landscape a little bit better. So.
And once again, John Mather.
And once again, John Mather came to the opening gala at Yerkes Observatory with me.
He spoke, didn't he? Didn't he give the?
He was the guest of honor. So
Got it.
They didn't make him speak, but I mean, he did. Oh no, we gave a lecture the day before the gala.
Yeah.
He did have to speak. You're right. We both had to speak. And then this is Twin Quasar, which is the piece that I did for the Whitney Museum's art port. And this was fun because we did, and actually Tinky came with me to New York City to the opening at the Whitney. And it was really, really cool because this piece is about gravitational lensing and how, you know, dark matter and, again, like massive objects warp light. So it was really, really cool to be able to be at the Whitney and hear, you know, the curators and the director of the Whitney describing gravitational lensing to the guests. And I was like, oh my God, we're doing it. We're bringing science to the art world. So yeah, this was commissioned by them. And we're going to show it again next year in the museum. But you can try it out yourself. It's available on desktop and headset. But yeah, it was a really cool project to do. And I collaborated with Mona, which is a friend of mine. He has a company in VR. Yeah, and just like a really, really exciting project, bringing in, you know, artworks from the Whitney's collection and combining it with space was really cool. And is this going to play? Oh, maybe not. Oh, bummer. No, my image isn't there. Because it's a video, because it's pulling from YouTube and we have no Wi-Fi right now.
Oh no.
Oh well. Well, I'll describe it really, really quick. In November, we're launching a piece about spectroscopy where we're doing visual representations of spectra using generative art. So it's creating beautiful images out of those boring graphs that we saw earlier. And sadly, we can't see the fun image now. No. Okay.
Yeah. So like I said, I run the social media for Webb. So if you're curious to see beautiful Webb images, once the government is no longer shut down, Instagram is a great place to see it. And we're at NASA Webb. There are a lot of accounts that are not ours that might look official but aren't. So we're at NASA Webb on Facebook, Twitter, and Instagram. And we also have a Flickr, and we have a huge image gallery there of the pictures of the building of the telescope as well as the science images. And we also have a YouTube.
Yeah, and this is my Instagram, where you can see all of these images become works of art. Also, you should say that you don't have a TikTok because you have a lot of fake
We do
TikTok
not have a TikTok. NASA has to have terms of service with these platforms, so NASA's on a very limited number of them. We're not on Blue Sky, we're not on TikTok, we're not on Threads.
Yeah, just so you know, those are all fake accounts because they're all saying that like
I
aliens are
know.
coming for us.
So this is, I think, sort of more in the Q&A period.
Yep.
We
just have pretty images.
we
for while you ask
curated
us
some
questions.
beautiful images from the telescope because we just thought you'd enjoy them. This is actually relevant to European Space Agency too, because this is was captured by our mid-infrared instrument. So Webb has several near infrared. That's like the closest to visible light, and then this is mid-infrared. It kind of they highlight different things, and you can kind of really see like the bones, quote unquote, of the galaxy and the structure within it in the mid-infrared really nicely. And this is a two colliding galaxies.
Yeah, I guess we can open up to questions if anybody has questions.
And we could flip
And we
through.
can just flip through the images.
These are, so we also see our solar system as well as things really far away, like the first stars and galaxies. We can actually even see small objects in our solar system, like comets and asteroids. And these are some of the outer planets, of course, Jupiter, Saturn, Neptune, and Uranus, which, all these planets have rings, and some of them have really, really faint rings. And the ability of the telescope to, see the rings is amazing. And it has also captured aurora on all of the planets.
Yep, question?
For you, Maggie, what's the most shocking or unexpected thing you guys have found out since launching the?
There were some things in the early universe that they, expected galaxies to evolve a certain way, and are learning it's not really that way at all. That maybe certain things happened earlier in the universe than we thought that they did. That's exciting to scientists, maybe not to the public. I think exoplanets again are so interesting because the fact that we can, see what the weather on another planet around another star is like is really amazing. So even though visually they're less interesting, I find exoplanets fascinating. And I think the aurora on Neptune was a really big deal as well, like that was able to capture that.
Well, wasn't the discovery of like some older galaxies than we thought there were because we saw it through a gravitational lens?
Hubble was able to use gravitational lensing. So she mentioned gravitational lensing a couple times. So in that first deep field that we released as well. So basically, if you have something that's really massive, like a galaxy cluster, its gravity is so strong that it will essentially warp space and time. And things that are far behind it, it'll warp its light and magnify its light. So it's almost like nature's magnifying glass, and it allows you to actually see the light from things that are even further away because it's coming through this like gravitational lens. And it often smears out the light, but still light.
The sculpture in the center there
is
representing gravitational
so even
lensing.
if the light is stretched weirdly, you can still analyze the light, and you can learn about the objects that emitted that light. So that's one way they're able to look at these first galaxies. I don't think they found like the first galaxies yet, but we found galaxies that existed when the universe was only a couple 100 million years old, which is amazing.
Yeah. I have a little bit of an obsession with gravitational lensing right now.
It's a very cool concept. Yeah.
Any other questions?
How long did the unfolding take?
2 weeks.
2 weeks.
Yeah.
Were you very invested also as an artist at the time, busy with it? With the unfolding and
Yeah, well, I followed the whole mission very, very closely. I also knew just how crazy this telescope was and how many single points of failure there were.
It was a very stressful, like there were so many contingency plans, and what if this doesn't work, and what if this doesn't work? And there's a video you can find online of how the telescope deploys. So first the sun shield booms come down, and then
all these
it unrolls.
Thin pieces of material have to not catch.
And the way they design the sun shield, again, those 5 layers of caps are so thin and folded so carefully, and they did all these they did tests and tests and tests on it, but everything just the material was so fine. And then they had to unroll the sun shield, and then they had to tension the sun shield layers, so pull them taut. And then the mirror has like almost like a drop leaf table. It has these mirrors on the side that had to be deployed, and the secondary mirror had to come down. So, but it went surprisingly smoothly. Like there were no really major issues, all these contingencies we didn't need. I was doing the social media for it. So again, we had all these plans of like, what if this happens? And what do we tell how do we tell the public? And, we even took pauses throughout this process, which were normal, but the public would freak out, like something's wrong. What aren't you telling us? Something's really wrong. It's like, nothing's wrong. You're not going to believe us if we say that, but nothing's wrong. And it was a really intense time because it was 2 weeks. We were working holidays because it launched on Christmas. So we deployed, we enrolled half of the sun shield on New Year's Eve, and then the telescope didn't like only half of it being out. So we had to do the other half. So it was like we finished that at 10:30 on New Year's Eve.
Yeah.
We worked New Year's Day, we worked weekends. It was very intense. And me and my team, we were like really punchy. So then the social media, because things were successful, we could be a little bit more fun because we had to be very careful in our tone up until then because the mission was over budget and delayed. But once it was clear it was successful and things were going well, we were getting punchy. We started pulling out like the Shrek analogies, like onions have layers, ogres have layers, the sun shield has layers. And the response to that was so great. People are like, I did not have NASA quitting Shrek on my bingo card for this year, and people were really appreciative of us being a bit like more fun because things worked so well, and they continue to go well. So it was 2 weeks, and then another 2 weeks for it to get out orbits, and it was extremely intense.
But also people had to, like Hubble launched and had a little bit of an issue, but
Right.
that's at least within Earth's orbit, so you can send
you can,
astronauts to go fix it.
We learned how to service Hubble to fix it, but we're 1.5 million kilometers away, so.
Yeah. So you can't, there's no fixing this telescope, there's no astronauts going to this telescope.
We did have lessons learned though, so there's a couple of things that they learned from Hubble, like always use independent verification of your numbers. Don't measure something and use the same machinery to verify those numbers. Use something independent. And the other thing that we did that Hubble did not was end-to-end testing. So it was, testing costs money and budget time, but it's really important if you really want to make sure that we don't make the same mistakes. So what we did, the telescope went to Johnson Space Center in Houston, Texas, and they have a big chamber there, and they set the instruments and the telescope upright, and they had like a sort of like a pretend light source. So they ran light as if it were observing something in space through the mirrors and the instruments in the exact path that light would have to travel to get into the instruments, and make sure that the mirror prescriptions were correct, that the instruments were functioning, that the entire system from end to end worked correctly. And they did not do that with Hubble.
Yeah. But you only had one shot for this. So.
We had one shot.
I think there's another question back there.
Sorry. Yeah.
Thanks so much for a fascinating talk. Building on what you've just been saying, Maggie, could you please share some more about the challenges of communicating science to social media?
Yeah. So I've been at NASA for like 28 years. And when I first started there, I sort of fell into science communication. I was really burned out when I finished my undergrad, and I had an internship there. And NASA at the time, this was 1996, had a lot of websites with like learning centers and how they like communicated and taught science to, for educators to use and for the general public to learn about what NASA science is. And then eventually, back in the 90s, people would have a list of websites they went to every day, like Slashdot was a big one. And then social media became a thing, and instead of going, people went to their social media feeds and information came to them. So you have to think like, okay, well, if we want our information in front of people, we have to go get their information. So that's why NASA has pretty much from the beginning had a very big social media presence. There are many, many accounts too. There's at NASA's kind of the main NASA account. It covers a lot of stuff though. So if you want more specific information, like just on Webb, just on Hubble, just on planets, there's a number of sub accounts that you can go to. But it's a real challenge because each of those platforms is different. They're mostly short form, and the algorithms run on like how engaging are you, how many people are interacting with you. So I feel like doing social media professionally is an interesting challenge because a lot of people don't think that it's a job. Like I have a Facebook, how hard can it be? Like, but when you think about communicating science information correctly, like we really, everything has to be exactly accurate. And it's very difficult to make science accurate and understandable in a very short form, and then make it like interesting, fun, engaging. So
Well, this kind of ties into how I make my artwork as well.
Yeah.
When I'm talking about galaxies or gravitational lensing or nebulas, I work one-on-one with a subject matter expert in that field. And I make sure that the artwork is absolutely correctly representing the research and the data that I'm using.
I mean, that's what I love about Ashley's work, though, because as an artist, she could take as many liberties as she wanted and being a conceptual artist, but I love that she actually wants to portray the science correctly, even if it's in an abstract way. She's still really concerned about like representing it correctly,
Yeah.
the concepts.
I don't want to say anything incorrect. So every work of art is like signed off by
Yeah.
an expert in that field.
Yeah, and I feel like between the two of us also, we've kind of built this little community, and I really love that Ashley built relationships with like people like John Mather, who again, nicest human being ever, but the fact that like, you know, he has been thrilled to collaborate with her multiple times and advise her, you know, she's really built like relationships with these people, and I think that's important too when you're communicating, is to kind of have people who want to help you communicate and do it correctly.
Are you also involved with like the scientific influences, like Smarter Every Day? He had this amazing visit to his dad.
Yeah, actually, I think his dad worked on the telescope.
Yeah, it's amazing.
He came out and shot a video there, but
Yeah.
kind of like me saying that like I'm doing this on my own time, and Ashley and I really worked within NASA's rules for collaboration, because NASA has very strong rules about endorsing things. So
Yeah.
oftentimes we'll allow creators to come in and see our facilities and to interview people or take video or whatever they want to do, and then they can go create their thing on their own, and that's their product. And we're just sort of allowing them access. It's really hard for us to collaborate in a true form because of endorsement rules with our government.
Yeah, I work in coordination with the NASA Webb team,
Yes.
not in collaboration, in coordination.
Yeah.
Yeah. Any other questions? No? All good.
We'll be around if you want to ask us questions.
Yeah, and I'll give you guys.
Are we looking at more images too?
Oh, we can look at a couple more images as well.
Yeah. So this one is my dress.
Yeah.
And that's the Pillars of Creation. This one actually is cool because there's an X-ray telescope called the Chandra Observatory. So X-rays are really interesting as well, because the light at high energies like X-rays and gamma rays behaves very differently than visible light or infrared light, which behaves more like a wave. So the way they build X-ray telescopes is very different, but it sees often hot gas. So the sort of like pastel-y colors in the background are where there's hot gas. So this is actually a composite of Chandra and Webb. So, and we have a number of it just thrills me too to have like composite Webb images, like just to have Webb images. This is a Herbig-Haro object, I believe. So this is a planetary disk. It's a young star that's forming a planetary disk around it. And those are direct images of an exoplanet system, which is cool. Again, you see small dot, but within that dot of light is like a lot of information.
A couple more.
The stars. This is half Hubble, half Webb, which I think is like a really cool comparison. And you can see the Hubble diffraction spikes at the top. Our Webb.
Cool. All right.
That's it.
You can download the presentation, follow us, and all the links to all of the virtual reality experiences are also on there.
Do we have one more question?
Oh yeah, one more question?
The infrared, that is of course an artistic pressure, if I can see it.
Well, yeah,
right.
False color imaging is.
Well, it's actually all false color. Like even Hubble's images kind of come in black and white, and there's these different filters, and they have to layer the images and choose colors. And she was talking about the image processors, Joe and Lisa. So when the data comes in, it's in these filters, and they have to stack them and assign colors. But it's not really like it's false color, but it's like also very scientifically chosen. Like they'll choose, redder to bluer, and the colors that they represent have scientific meaning in them.
Relative to one another.
Right, they're relative to one another,
Yeah.
so they
'Cause you
need to
can't see in
translate it,
infrared.
yeah, into what your eyes can see.
It's like picking it up and putting it into the visible light
Right.
spectrum.
But infrared light is so close to visible light that, you know, the images you're seeing don't look so far off from Hubble images, whereas the X-ray images often are like blobs of hot X-ray emitting gas and that look very different than Hubble and Webb.
So yeah, please follow us, and I'll walk around the gallery and explain more of the sculptures to you in depth if you have any additional questions. And thanks to
for coming.
space.com.
Yep.
I think we can kill the stream now.
Yep.
Thank you.